Thank you for joining today's webcast on Creo Fatigue Advisor. If you haven't been on one of our webcasts previously, please take note that you are in listen-only mode. If you'll type any questions into the box on the right, we'll get to as many possible following the webcast and demonstration. My name is Jason Hardebeck. I'm the National Training Manager of the PTC Solutions Group. Sukumar will be doing our demonstration following a quick introduction. Like I mentioned, I'll start off with a quick introduction to BWIR and who we are as a company. Hand it over to Sukumar, who'll kind of take you through how Creo Fatigue Advisor can help your company make better products that are more sustainable, more durable. Then we'll follow up with a quick question and answer questions. For those of you unfamiliar with BWIR, we are the IT and Engineering Solutions Group of Barry-Wehmiller, a company that's been in business for 130 years and approaching $2 billion in revenue. We work with companies in the development spectrum from conception all the way into the retirement in areas such as today CAD/CAM with ERP, PLM, business asset management, customer relationship management, and most importantly, tying all these different areas together. You'll see here a quick description of 3 different core groups. We're going to focus on the PTC Product Development Solution groups today. We also do engineering solutions, everything from product design, FEA work. We do complete machine design. We also do manufacturing process controls, electronic controls, just about anything you can think of on the engineering side. And then we have a solutions group that focuses more on the larger scale enterprise resource planning, customer relationship, business intelligence solutions, pretty much tying everything together. As far as PTC products goes, we are one of only 4 platinum level PTC partners. We support the full line of PTC products and training. We have 7 training centers across the U.S. We also provide on-site training, mentoring. We have some of the best application engineers around. They average over 15 years experience using PTC products in both real world and classroom environments. Here's a real quick view of some of the customers we work with across all of our different groups. You'll notice these are a lot of larger customers, but the same problems they face every day and challenges apply to pretty much every company. I'm going to go ahead and turn it over to Sukumar, let him get into the demonstration. Give you control real quick here, Sukumar.
Jason, can you see my screen okay?
Yes.
All right. Good afternoon, guys. We're going to talk about Fatigue Advisor today. So just to give you a brief overview as to what Fatigue Advisor is and what it can do, you notice that most important is when do I use this type of analysis, right? So when a model undergoes repeated cycles of loading and unloading, it can also fail even if the stresses are below the safe values. Okay, so the mechanism that causes is called fatigue. So what PTC's Fatigue Advisor allows you to do, it allows you to predict and improve the fatigue performance for your design earlier in the design life cycle. Notice also that the Fatigue Advisor works entirely within the Creo Simulate structure. All you need to do is simply run a regular static analysis and make sure you define fatigue material properties. Then you determine what kind of loading you have and how many cycles you want this part or this assembly to last, and fatigue wanted to be successful is 50 or 50,000, my bad. So if you say 50,000, it's good for up to 50,000 landings and takeouts. But if you go ahead and say you're designing a crankshaft, you want to maybe put like say 5 million cycles or 10 million cycles and so on and so forth, because the crankshaft kind of rotates more than the plain land, of course, right? So the life kind of gives you how much cycles your part can last till it fails. Log damage is another quantity that kind of gives you the percentage of damage on this part due to loading, right? So it shows the ratio between accumulated fatigue cycles to the total number of cycles to failure, okay? So note that the life and the damage, the results are logarithmic in nature. So when we do the demonstration for fatigue, I'll show you how to calculate based on the result as to how many cycles this particular model will go before it fails. You can also calculate factor of safety, right? So let's say, for example, you want the model to run for 10,000 cycles, and it kind of like doesn't fatigue till about 50,000. So what it does is it kind of reverse calculates and calculates the factor of safety that you have on the particular part. You also have another factor which says confidence of life, right? It kind of tells you in 3 stages if the model, how much confidence you can have on certain areas of the model, or where the model is going to break first, where the model is going to break second, so on and so forth. Now, in terms of material type, you also have different options here that you can say, hey, it's an unalloyed steel, it's a low alloy steel, you have titanium alloys, or you can also use aluminum alloys. Now once you select this material type, you also have options to go ahead and pick surface finish. All these different factors affect your fatigue life. So in the surface finish, as you can see, you can pick polished, ground, good machine, average machine, poor machine, hot rolled, forged, cast, right? All these different options that you have for surface finish, because surface finish also affects fatigue. Surface finish affects it, your material type affects it, your loading condition, your constraints, everything affects fatigue properties. Last but not the least, you also get to specify the fatigue strength reduction factor, okay? Now, your fatigue strength reduction factor is generally greater than 1. This is used to kind of like reduce the endurance limit to account for unmodeled stresses. For example, if you have notches in your part, or if you have welds in your part and you're not actually modeling them, then you can use this KF, or a fatigue strength reduction factor, to account for that. Okay, that's what fatigue strength reduction factor is. We'll get into advanced tuning in a little bit. Let me go ahead and show you how to set up this fatigue analysis. All right, so with constraints, okay, that I'm fully constraining it over here. And then I have a loading condition where I'm applying a moment where the total load is acting at a point in space over here. It's applied to those two surfaces. I can preview it to just show you how the moment's acting. So this is a brake caliper, okay? So once I set that, I'm also going to go in and show you the material properties. By default, the PTC material properties directory does not have the fatigue materials in there. So you see I'm using the fatigue property right there. I have different types of material. I have different types of surface finish. And here in this part, I'm using one because I don't have any unmodeled stresses in my model. I'm not welding anything. I did not take away any notches. So, you know, I don't have anything that's contributing to the fatigue strength reduction factor. Also notice that you need the ultimate tensile stress over here. So I have this material with fatigue properties, and I'm assigning it to this particular model. Once you do that, you go ahead and run a base static analysis. Okay, so I'm going to go ahead and edit that for you. So you see I have a constraint set here. I have a load set right here. I'm running a single pass. Again, if you were a part of the last webinar that we did, we went through the advantages, disadvantages in terms of when to use a multi-pass, when to use a single pass, how do you judge the quality of your solution, how do you refine the quality of your solution in terms of element edge orders, etc., etc. Okay, so here just because I'm just trying to do a quick demo of fatigue, I'm just running a single pass right here. So once you run this analysis, you can go ahead and check out the results for it. So I'm looking at a fringe plot for stress, and you can clearly see where the stress concentration is higher. Okay, that's where my stress concentration is, and maybe I'm still below my allowable, so I'm fine with it. But it just shows you a dark spot over here. You can also try to animate it. You can also deform while I animate. I might want to reduce the speed. You can see how that works. All right. So once that's done, we're going to go ahead and set up fatigue analysis. So in this fatigue analysis, how do I start it? I go File, New Fatigue. That's what I do. Okay. When you do that, you get this window. You can go ahead and enter a name. Right here, it asks you for a desired endurance. So how many times do you want this model to have or to survive the loading? So I have like about 2e⁻⁷ cycles. Okay. I also have constant amplitude. If you want to, you can choose variable amplitude, where you can load an ASCII file and have different loading conditions, vary the amplitude of your loading. Your amplitude type, mine is 0 to peak. You can also go peak to peak, and you can also go user defined, where you can enter your minimum and maximum load factors. Notice that by default this box is not checked, so you have to check it if you want to calculate the factor of safety. Again, here I'm going to check a box over here to use the previous design study for static analysis and the loading conditions. So setting up the fatigue analysis is very simple and very easy. Okay, you see that it 918 cycles. So within 918 cycles, this fatigue failure is starting over here in this area. So now knowing this, the designer can go ahead and change certain things in terms of, hey, this is going to fail here before the 2 million cycles that we want it to, right? So you can predict that very easily, very quickly using the fatigue log life result. The next result that I'm going to talk to you about is log damage, right? Log damage kind of shows you the ratio between accumulated fatigue cycles to the total number of cycles to failure. Okay, so again, even this is exponential in nature. So you can see that the total number of cycles over here in red is 20. So you see that, so these parts, this area is pretty good. But here you can see that the log damage here is done very quick, even before the desired endurance is there, and you can just do a log of that to kind of get when or how much damage is going to be occurring, or when the damage is going to be occurring over here. Okay, so if the value is, say, for example, 0.5, then it represents a loss of 50% of useful life in the model. Okay, so that's how you would read the log damage. All right, notice that this is exponential in nature, so you need to use you need to find this as a log instead of directly looking at the result right here. So the next thing we're going to talk about is factor of safety. All right, so the factor of safety kind of shows the permissible factor of safety on the input load. So when the fatigue life is calculated for your model and it is greater than the target design life, the software kind of carries out a back calculation to determine a permissible factor of safety on the input load. This represents the extent to which the amplitude of the load can be increased without compromising the target design life. Okay, so that's factor of safety for you. The last option here is confidence of life. Now what confidence of life does, it gives you like 3 options. The red is 1, yellow is 2, and green is 3. Okay, so anything in red shows that there is fatigue, a failure. $2 million endurance to 3 times 2 million, which is 6 million cycles. Okay, so which is if the value or the failure occurs between 2 million and 6 million, which is 3 times the desired endurance, it shows in yellow. And anything that lasts past 3 times the desired endurance is the desired endurance shown in green. Okay, that's what confidence of life means. So note that these calculations are done using our internal settings, and I hate to use the word, but internal settings are more for people in terms of if you're a novice in terms of fatigue, then you might want to stay with this. It's very conservative, the results are, okay, it's super conservative. So unless you know fatigue theory and how different models affect your parameters, you should not go change the internal settings that are there out of the box. Now that being said, the next thing I'm going to talk to you about is how do you tune the fatigue advisor if you are, say, hey, I know fatigue, I know how it works, I've been to, it's probably a semester-long class at grad level. So some of the things that you can tune for fatigue is how it calculates or estimates its cyclic material properties. So notice that by default, your fatigue advisor estimates your cyclic material properties from the type of the material that you specified and its tensile ultimate stress. Notice that this is purely an approximation. Okay, so if you want to increase the accuracy of your analysis, what you can do is you can use an ASCII file to enter specific cyclic material properties. Okay, now you can do that by setting this sim_fatigue_external_mat data config.pro option. Now if you go ahead and set this option, you notice that you need to create and assign a material to your model, right? Once you do that, you assign your ASCII file with the same name as the material, and you save it as a file extension of .mat, okay? And you place it in your working directory. I mean, your working directory is where your model is. What Simulate will do is then it's going to follow your ASCII file for the cyclic material properties for that material. Okay, so that's one parameter that you can tune using config.pro options. Another parameter that you can tune is material confidence level. By default, you notice that Fatigue Advisor sets the material confidence level to 90%. Okay, this is very, very conservative than the confidence level that's used in most of the fatigue modeling tools. Now, if you understand the effects of material confidence level theoretically, then I would suggest that you go use this particular config.pro option, which is sim fatigue confidence level, and you can change it. Now, I personally would kind of want to go 50%. Okay, that's my experience in terms of what kind of analysis I run. Okay, so 50% of confidence level would be good. By default, it's 90%, and it is conservative. The next factor that you can use to tune your fatigue advisor can import an ASCII file and load it up, right? So that's another place where you can actually play with ASCII files and change your loading, etc. Right? So Fatigue Advisor is a separate module altogether. It's very simple and easy to use. It gives you good estimations in terms of how long your part's going to last, where the failure is possibly going to happen, and then you can go ahead and tweak your model and run more fatigue tests just to make sure that your model passes it, right? It can be also used, as a test in terms of, hey, I've run a real-world test, or strength test, or a fatigue test, and then I want to correspond to my results. In that case, you might want to have a fatigue expert go ahead and look at these tuning parameters that I spoke to you guys about, and make sure that those match. In that way, your results are not super conservative. Okay? So that's what I had in terms of fatigue. So you can see that setting up the analysis is very, very simple. Setting up the material properties is really simple. We went through all the different options that you have in terms of material type. You have these 4. Surface finish, you have these options. And we also spoke about fatigue strength reduction factor. It's an empirical value, so you can find it anywhere. Unless you have welds and you're not actually modeling the welds, you would use this to accommodate for that. Now, if in my particular model, I don't have any unmodeled stresses, like say I don't have any notches, I don't have any welds, so I'm just using 1. Okay, that's one factor, and you notice that you also need your ultimate tensile stress. Once you assign the material, you run a simple static analysis, and then in your fatigue, you enter your desired endurance. You choose your loading amplitude type. You want to set your factor of safety, and you want to use your static analysis as your previous design study. So that's how simple it is to set up a fatigue analysis. And then we also went through different results type in terms of what log life does, what log damage does, what confidence of life is, and what factor of safety is. This is what Fatigue Advisor kind of gives you. All right, Jason, you there?
We're here.
All right, that's pretty much it, buddy.
All right. Let me pop back to my screen here. We'll finish up with a real quick question and answer, just a couple poll questions. All right, for the first poll question here. Do you currently use Creo Simulate? Just give it a few seconds here, and we'll get to the second poll question. So it looks like about half and half. Poll question 2, we're going to continue with a Creo Simulate theme next month. So we're trying to see if you guys would prefer it to cover simulations interaction with either behavior modeling or mechanism design. You could please fill out the poll question. Once again, there's a pretty good number for both. Maybe Sukumar will have to do 2 next month. You never know. You can go back and view or replay this webcast. You go to our website under Webcast and view Arch's webcast. It should be up later on today, and it'll also be on our YouTube page. For those of you who don't know, PTC is currently running a time-limited offer to save 50% on simulation software. This is good through June 20th. You can reach out to us or your local sales rep, and we can help you get this taken care of if you're either looking to add Simulate or possibly expand it in your enterprise to maybe having all your engineers use it throughout the design process rather than just using it at the end. And please feel free to reach out to anybody if you have any questions. You'll see my name on here, Sukumar's name and email also. So please feel free to reach out to us with any questions. Let's go ahead and get to any poll questions we have here. Do we have? Why did you have an AL 2014 for the brake caliper analysis, but the UML was steel? Sukumar?
Oh, the AL steel is just the material. Okay. The aluminum is the material. I'm saying that it is an alloy of steel, right? So it's just a preference. So you can use different combinations if you want to.
Right. How does Fatigue Advisor work for an assembly?
It'll work the same way that a static analysis will work. But you have to be careful in terms of, when you have an assembly, if you take the entire assembly in as bonded, that means you're assuming great connection between the parts. You're not worried about the connections as to how the parts are fused together, right? Over there, if you have two parts, say for example, welded, and you're not actually modeling the weld and you're actually considering them to be bonded, then you might want to include the fatigue strength reduction factor. You might want to add that factor over there more than one to accommodate for the unmodeled stresses induced by the welding process. Or if you're using bolted connections, right? Now instead of using a bolted connection, if you are just saying, okay, these two things are fused together, so I'm just going to consider it to be bonded, I've noticed that your result might be different because if the bolt was there, the bolt might fail before the part fails. So it's kind of a little different, but the process or the procedure is very similar.
One more. Will plastic be added as an option in the near future?
Say that one more time.
Will plastics be added as an option in the near future? Are you aware of?
As of now, it's strictly isotropic. Nothing in terms of elastoplastic or hyperelastic materials in there. I cannot answer that question because we've requested. There's a lot of enhancement requests for plastics in terms of that, but we haven't heard much. So I wouldn't say one way or the other, but I don't know.
Can you use fatigue analysis along with the modal simulations?
Can you use fatigue analysis with the modal simulation? Huh. Now you see the point of actually doing a modal simulation is more or less trying to find out the natural frequencies, right? And the mode shapes at that natural frequency. So you might actually run a dynamic analysis to where you want to measure the effects of this mode your part being put on a shaker table per se. So if you want to run a dynamic analysis, you have to run a modal analysis to first calculate the natural frequencies. Then you might want to have a dynamic frequency or a dynamic time analysis where you excite the model, probably using base excitations or load excitations, and then take that up into fatigue and say, okay, if this keeps happening over a period of time, how long will this part last? Because modal analysis just tells you what your natural frequency is, and that's pretty much it.
That looks like all the questions we have in the queue, so thank you, Sukumar, for your time, and thanks everybody for attending. We'll send up a quick email with a thank you and the links to both the webcasts. Please let us know if you have any questions.